Good morning, biology world. Purpose of this video is for you to be able to finish up the Earth and Life, the bad notes. I think we went through 19 or 20, but also some people might have been absent. Some people might have been writing their notes by hand and maybe you weren't able to keep up. So remember, class notes always need to be numbered. If you're doing a Google Doc, you're going to need 23 rows and 2 columns. If you are writing by hand, you'll just simply need to draw a line down the center of your page. We're going 1 through 23. Remember, if you wish not to listen to what I'm saying in the video, it's totally fine. I don't take it personally. I will indicate when I'm getting ready to move to the next slide by pointing at you. So you know when to pause if you are still writing or typing. Also remember, I'm not going to spend as much time on each slide as I do in class, as this is a video and you can pause it, fast forward it, replay it as many times you like. All right, here we go. Carrying capacity, the book's definition: largest number of organisms that a given environment can support. And the carrying capacity is going to be influenced by a variety of factors. It's difficult to predict for humans because our species is very diverse and we're in different countries, and those different countries have access to different resources, different medical facilities, different educational systems. So we do a lot of things at different rates. So it's really, really difficult to predict for us. My personal opinion, we're at about 7.8 billion people. I think the Earth's carrying capacity probably was exceeded years ago. I think probably it's closer to between 6 and 6.5 billion. And in my opinion, and I'm not a negative person, but unless we really slow down our growth rate, there are going to be a lot of people starving in the coming decades. All right, current resource consumption. This is pretty disturbing. Right now, we need 1 3/4 Earths to continue to use the resources at the level that we're using them now. That's a problem. We don't have more than one Earth. The next 30 years, we will need 3. So we are probably past our carrying capacity. And this is just information I found out of the book and online. Again, my personal opinion is we are well past the Earth's carrying capacity in terms of humans. All right, hopping ahead. What affects carrying capacity for humans? Food, fresh water, sanitation, cleanliness, disease, access to medical care. Personal opinion again, I think that if we had closer to 6 billion people on this planet rather than 7.8, I think we probably might have a hold on the pandemic. We certainly would not have the rate of transmission. We would not have the speed of transmission. We probably would have fewer deaths, probably would have many fewer less that have become infected, because disease gets transmitted through dense populations, and we have dense populations all over the world, especially in cities. For other organisms, basically it's about the same. Plants obviously need nutrients. Humans, we're also affected by pollution to a certain extent. It kind of depends on the medical care that we get. The big difference is space to live for organisms. Humans, we're really good at cutting down forests and building houses on them. We're really good at taking just wide open spaces, grasslands, and putting houses on them. We're good at building on top, building high rises. There are even countries that have homes underground. So we figure out where to live. Organisms do not have that same luxury. Factors that affect population size: 2 growth factors: births, scientific word is called natality, and immigration. That means people coming into a country or organisms coming into a population. And then 2 reductions: deaths, also known as mortality, and emigration is the opposite. Immigration means organisms leaving a population. Exponential growth. We're going to abbreviate that as capital EG. Exponential growth occurs when you have ideal conditions, unlimited resources, a constant reproductive rate. The human population currently does have a constant reproductive rate. And also, a characteristic of exponential growth is increased competition. Remember in the Before the Flood video when DiCaprio was talking to President Obama, climate change is actually considered a national security threat for America. When countries in the future, and there are countries currently suffering, but I mean in the future when drought sets into areas that are already dry and fresh water is not as available, and millions of people in populations of certain countries are starving, it's very possible that leaders of those nations could demand assistance from the wealthier nations like the US and other developed nations. And if we don't supply them that assistance, it's very possible wars could happen, especially on border nations, nations that are right next to one another. Of course, that would be Mexico and Canada for us. Fortunately, Canada's doing pretty good, okay, and Mexico it's still developing, but it's a relatively wealthy nation. But that could create some conflict between nations, between the nations that have and the nations that have not. All right, hopping ahead to the next one. All right, I'd like you guys to draw this. Again, don't worry about labeling all the units. Definitely put population or pop size in billions. I would have 1 down here and 6 up here. You don't have to fill in the other numbers. I have 8,000 BC down here. Make sure to label your axis, your x-axis time. Have 2,000. As you can see, our population is going up. This is at 6. Remember, our population is closer to, let's see, this is probably about 7. This is probably about 8. So our population is probably about here now. And obviously it's still going almost straight up. So take a few moments to sketch that. We refer to this growth curve as a J-shaped growth curve. If you had a line across here, it would look like the letter J. All right. So a J-shaped growth curve represents an exponential growth. So what's the problem with that? No species, and we know of many species. Ecologists study this, population biologists study this. Many species that have been in exponential growth. No species in the history of this planet has ever survived this. Now, I'm not saying like if you get past the carrying capacity, you become extinct. Okay, I'm not saying that. But there's a crash. There's an eventual crash, and that usually comes about because of starvation or disease. Both of those, I'm sure, will come into play for the human species. Like I said, I think we're well past the Earth's carrying capacity. We're already cutting down forests to graze cattle on, to harvest the trees, to grow crops on. And these forests, there aren't very many of them left. And really, the majority of that deforestation has happened in the last 20 to 30 years. I'm not sure what it's going to look like in 20 more years. All right, getting ready to hop ahead. Okay, please use this as an opportunity to practice with your notes. Why is it hard to predict what the human carrying capacity is on Earth? If you're not sure, take a look back at number 2. It's one of the reasons why I number the notes. It makes it easier for me to tell you where to find the answers. Yeah, it's because humans do things at different rates. We reproduce at different rates. We use resources at different rates. What was the other one? We consume at different rates. We pollute at different rates. All those are correct. All right, 5 things that affect carrying capacity. Again, take a look at number 4 and number 5. A lot of them are similar. Yeah, so food, fresh water, resources. What were some of the others? Competition, sanitation, nutrients for plants, pollution if we're talking about organisms other than humans. Yeah. What is frightening about the human's exponential growth rate? If you can't remember, take a look back at number 9. Yeah, it probably means that we're going to have a crash. Maybe 20 years, maybe 30 years, maybe 40, 50 years, depending on how lucky we are with climate change. But yeah, we are not exempt from that. Humans are not smart enough and resourceful enough not to have a crash because resources are more limited than they ever have been, and we're adding I don't know how many hundreds of millions of people to the planet every year. I think we add a United States about 330, 340 million people to the population every year, which basically means about another billion every 3, 4, 5 years. We're going to hit a crash, and let's just hope that wars don't break out when it happens. All right, onward. So please abbreviate ecosystem as capital ES. So ecosystems are stable when the environment is stable. So obviously, the environment, with a few exceptions, deep ocean, some of the permafrost regions, tundra regions on the planet, although they're starting to melt, the environment's not stable, which means that many ecosystems are not stable. Environmental stability, reduced environmental stability or no environmental stability, pollution, warming of the atmosphere, droughts, acid rain, severe weather. I mentioned this when we were taking notes yesterday, but hurricanes. Hurricanes, I was watching the Weather Channel about a week ago. They have already had as many hurricanes this year, and there's about 6 to 8 weeks left in the hurricane season. The most hurricanes that we've ever had affect the United States. And there's probably going to be another 6, maybe 7 more over the next couple months. And not only are they more frequent, but they're stronger. Go watch a video on how hurricanes form and how hurricanes gain their strength. It's related to evaporation, and evaporation is a direct correlation with the temperature of the water. And if the atmosphere is warmer, then the surface water is going to be warmer because remember, there's a lot of contact there. And it's called latent heat. Latent heat actually fuels. It's like throwing gas on a fire. It's like putting your pedal to the metal if you're driving a car. And these storms are getting bigger and stronger, and the future holds more storms and stronger storms. I would hate to live in a hurricane region in this country. Matter of fact, I ain't moving to the south. All right. Biggest threats to ecosystems. Human activities primarily. By the way, when I list like 7 or 8 or 9 things, if 2 or 3 of those are obvious to you and you already know that these are threats to ecosystems, you don't need to write everything down. But there is a very, very fine line between being efficient, picking the ones that you didn't know about already or they're not as obvious, being efficient, and being lazy. Right? So, for example, if you wrote down 2 things, I'm not giving you credit for number 12. Okay. So pollution, deforestation, global warming, ocean acidification, mining, habitat change. Habitat change, we usually plant crops or we raise cattle or we just harvest the trees. Over harvesting, primarily fish species. Use of fertilizers, water pollution, nitrates, phosphates get into water. They cause algal blooms. And the scientific term for an algal bloom is eutrophication. Actually, it's cultural eutrophication because it's tied to humans. Yeah. And if you want to know a big way that you can help out, and this isn't just you, try to influence your friends too. I mean, as the Crash Course videos, he mentions, I think his name's Hank, so often, we love cows. We do love cows. Cows take a tremendous amount of space. They also require feed, and we use a lot of land just to grow feed for cattle, and they produce a ton of methane. And they're probably one of the least healthy meats for you to eat. So reduce the amount of beef that you eat. Eliminate it from your diet if it's not that big of a deal to you. I mean, every once in a while, I've got a buddy who used to love beef, and we had a conversation last week. He really, in the last 2 years, has only eaten a couple burgers and one steak, and he's at the point where he's like, I'm not eating beef unless it's a really good steak. And, you know, if you go out to a nice restaurant or, you know, buy a really nice cut of meat at the store, he's going to limit it to that. And he's going to transfer over to chicken and pork. I personally love pork. Not a huge chicken fan. I love pork and I love turkey. I love ground turkey burgers. I put ground turkey in my rice, put ground turkey in casseroles. Anyway, that is a huge way that you could help the planet, is by reducing or eliminating beef from your diet. And every once in a while, give yourself a reward by having some, but and also spread the word. I mean, in this country especially, we are addicted to beef, and it's so bad for the environment. Okay, moving ahead. Biodiversity. We're going to abbreviate that as capital BD. It's the sum total of the genetically based variety of all organisms in the biosphere. That's the definition right out of the book. Is it threatened? Yeah. You bet. When our extinction rate on this planet, we have more extinctions per day, per week, per year than we've ever had, you better believe biodiversity is threatened. And biodiversity is a direct relationship to ecosystem health. If you have low biodiversity, the ecosystems are not healthy. Uh-oh, sorry about this. I could have sworn I had this all worked out. Hello. My bad. Yeah, so currently we have about 1 million animal and plant species are threatened with extinction. This is more than we have ever had on the endangered species or the vulnerable threatened species list in our history. And it's primarily habitat loss, habitat destruction, pollution, you name it. Pretty much all human activities are causing more extinctions than we've ever had. And just think that if one of these rainforest species that are now extinct, that we never even had an opportunity to study, if we could have got a compound to cure cancer from that. I don't show it in class because they show women's breasts, the native populations in the Amazon. But if you want to watch a movie about, you know, deforestation and what rainforests have for us in terms of medicines and compounds, check out the movie Medicine Man. It's probably 20, 30 years old. It stars Sean Connery, who just, God bless him. Love Sean Connery, just passed away recently. All right, moving ahead. All right, just extinction? Is that all we need to worry about? No, some species will recover. Well, they might not become extinct. I don't want to say recover, but their low population numbers might be so low that they have less genetic variation, less genetic diversity within their population. And this really makes them vulnerable for changes in their environment. And as you know, Organisms are experiencing a high degree of change to their environment. What's the problem? So larger populations have more genetic variation, meaning you have differences, different characteristics, differences in individual characteristics within the species. The more variation you have within that population, the more able that species is to handle changes in their environment, dramatic changes, harsh conditions. Whereas if you have very little genetic variation in a population and you have an extreme change to their environment, it's very possible that they're not going to be able to adapt fast enough. Something the guy said, Hank said in the video yesterday, is that the environment changes. I mean, it has always changed. The problem is that species in the past have had hundreds, if not thousands of years to adapt to changing environments. We are changing our environment in a lifetime, like within 50 to 100 years. Organisms through, this is something you'll learn later on in biology, through crossing over when gametes, sperm and egg, are formed, and through mutation, which we will learn next semester as well. Those are the biological sources of genetic variation. That stuff takes time. You can't evolve. Well, some species that reproduce really, really rapidly and have some really beneficial mutations might be able to evolve in a short period of time, but it's rare. Organisms need time to adapt to environments, and if they can't adapt to the environment, they die. All right, is it the same threats as to ecosystem stability? Yeah. Plus biodiversity and ecosystem stability, they're related. Populations disappear from ecosystems and cause major changes in feeding relationships and in many other ways too. Remember those ecosystem services that I think Hank said we get about $45 trillion per year, and the global economy is $66 trillion per year. You remove some of these organisms that are vital to ecosystem services, that's going to mess up the environment, or it's going to cause humans to have to pay for some of this stuff. Big one, bees, pollinators. Bee populations worldwide are decreasing. If we had to pay for what they do in terms of pollination for our crops, OMG, farmers are freaking out about the bees. And it's mostly changes in temperature. Of course, there's this, what's it called? The murder hornet or something that's moving its way across the United States, a really big hornet that's killing bees. And remember, this is a species that was never able to live in the environments it's now living in, and that's, again, related to climate change. All right, getting ready to move ahead. All right, ecosystem stability depends on the stability of the... Take a look back at number 10 if you're not sure. Yeah, stability of the environment. And the environment is not stable. What are 5 of the largest threats to ecosystems? Again, there were lots of things for you to choose from. Take a look at number 12. I bet you just off the top of your head, without even looking at number 12, you could come up with 5. Let's see if I can. Yeah, I'm tired. It's early in the morning. Let's see. All right. Pollution, deforestation, global warming, ocean acidification, mining, habitat change, overharvest, use of fertilizers, which is a form of pollution. Okay. All right. Not only do human activities affect ecosystems, but they also affect... Take a look at number 15. 16. They affect biodiversity, and they affect the extinction rate. Good. All right, here we go. This is where we ended yesterday. So there are natural factors that also affect populations and the size of those populations. They're density dependent factors, things that depend on the density of the population. The more dense a population means the more organisms in a certain space. The less dense a population, the fewer organisms. They're more spread out in that space. Density independent, these are factors that it doesn't matter how many organisms are there, they're still going to affect the population size. All right, here we go. So limiting factors, primarily limiting nutrients. If the nutrients are there or they're not. So it doesn't really matter how many organisms are there. Competition for food, competition for habitat, competition for water. Those are definitely affected, by how many organisms are in the population. So predation is the fancy scientific word for being eaten. And obviously, predation depends on how many organisms are being preyed upon and how many organisms are doing the preying, the predators. Or are doing the predating, I guess would be the correct way to say that. All right. Oh, goodness, Paulus. I thought you had this all figured out. This might be a problem. Oh. Yeah, it's kind of a problem. Hold on a second. Sorry about this, kids. Thought I had this all worked out. Let's make this smaller. Now we should be good. Yeah, we should be good. Okay. So health, parasites carry diseases, bacteria, diseases. So definitely the ability for diseases to spread and parasites to infect host organisms is going to depend on how many organisms are there. Also the environment, drought and other extremes, extreme types of weather. Those don't discriminate. They don't depend upon how many organisms are there. They're going to happen regardless of who's living on the planet. All right, so number 20 is where we started, where you should be starting, assuming you were caught up as of yesterday. So do humans affect population size? Of course we do. Again, extinctions are up, and that's primarily caused by humans. Some populations will survive. They will not become extinct, but their population numbers might be smaller, which again reduces genetic variation, which reduces the diversity within that population, which makes them more vulnerable to environmental changes in the future. All right, moving ahead. Human impact on the carbon cycle. We have a huge impact on the carbon cycle. All right. Examples. Deforestation. It's a double whammy. Trees can't remove CO2, which indirectly increases the amount of CO2 in the atmosphere. And we usually burn them, or we at least burn the vegetation around the trees, which adds a ton of carbon dioxide to the atmosphere. So we can't take it out, and we're adding more. Woohoo! Humans are stupid. Ocean acidification. So CO2 diffuses out of the atmosphere because it's in high concentrations in the atmosphere. It goes into the ocean. Oceans and Oceans and forests and fossil fuels underground are huge carbon sinks or reservoirs. You're going to need to know that for the test. Primarily underground and fossil fuels and oceans, carbon reservoirs. But when carbon dioxide reacts with water, it forms carbonic acid, which is a weak acid, and that actually can dissolve corals and organisms that have shells, or prevent them from making new coral or making new shells, because it lowers the pH of the ocean. Burning fossil fuels. Goodness, here we go again. It's weird. Every time I make these videos, the box is in a slightly different spot. I've got it marked on my computer exactly. It's got to be below here, and it's got to be to the left of here, and it's different every time. I don't get it. I tried, kids. I really did. I mean, you can see the bottom bullets. They're moved over to the left. Burning fossil fuels, big problem. Huge amounts of carbon dioxide and methane are entering the atmosphere. Land use, how we use our land. Instead of plants absorbing carbon dioxide, we're building cities, we're putting concrete down. And concrete production itself produces a ton of carbon dioxide. So maybe instead of using concrete, we need to figure out some other. I understand concrete's cheap because you get it from limestone, and we find limestone all over the planet. But maybe we need to figure out something different to use other than concrete in the future. I'm sure there are alternatives. I'm not sure what they are, but I'm sure they exist. Concrete, use of limestone, puts huge amounts of carbon dioxide into the atmosphere, and that's primarily because limestone is calcium carbonate, CaCO3. And when you break it up or you dissolve it, the carbon dioxide is released from the other oxygen. CO3 goes to CO2 plus an oxygen. And of course, global warming, climate change. We're melting permafrosts, releasing methane, which leads to more global warming. You might learn about this if you take my AP Environmental Science class, but there are things called feedback loops. And if you're concerned about the future of this planet, you might want to go watch a couple videos on feedback loops, because feedback loops can be controlled to an extent. But when we go past a certain point, the Earth starts doing it itself, and we no longer can control it. There are two types of feedback loops. There's a positive feedback loop and a negative feedback loop, and a lot of my students get confused on that. They're like, oh, no, it's bad for the planet, so it's got to be a negative feedback loop. Oh, it's good for the planet, so it's got to be a positive. No, it doesn't have to do with its relationship to humanity. A positive feedback loop is when a problem like climate change, warming in the atmosphere. Okay, warming the atmosphere melts more permafrost, which releases more methane, which warms the atmosphere more, which melts more permafrost, which releases more methane, which heats up the atmosphere more. So it continues to cascade and make the problem worse. That's a positive feedback loop. Whereas a negative feedback loop is something that counteracts an effect. So for example, all the smoke we had in the atmosphere, especially in the valley during the wildfire season, smoke and particulates in the atmosphere actually, solar radiation, incoming solar radiation bounces off and goes right back out towards space. So that actually reduces the amount of heating on the surface, which reduces the amount of heat absorbed by greenhouse gases in the atmosphere. So that actually kind of cools down the planet a little bit. And I'm not suggesting let's just go burn everything and put stuff in the atmosphere so it reflects the stuff off, but it counteracts global warming or climate change. So that is a negative feedback loop. And again, my kids get confused on these all the time. They're like, oh, that's good for us, so it's got to be a positive feedback loop. No, positive makes it worse. Negative counteracts. It makes it actually a little bit better. All right, getting ready to move ahead. Okay, I would like you to draw this. And I have a question for those of you. So this is carbon dioxide in parts per million. And this is basically about the last, this is about 2020. So this is pretty current. Question for you, for those of you that think you're smart And I'm not suggesting you're not smart. I just, some people think that they're smart and they know carbon dioxide, and I can't give you any more hints. Why does the line go up and down every year? Why is there a high point in carbon dioxide in the atmosphere and a low point in carbon dioxide in the atmosphere every year? I mean, obviously the trend, so you're sketching this, right? Draw this, okay? And yes, fill in all the units. This obviously is time. So it's trending upwards, okay? I think in a video we watched recently, there's more carbon dioxide in the atmosphere than there has been in the last 50 million years. Pretty insane. Okay, how much carbon dioxide? I'm not worried about carbon dioxide as much as I am the methane that's coming from the permafrost. That's what's freaking me out, because I got kids, and hopefully I'll have grandkids someday if they choose to have families and children. And if I'm lucky enough to survive long enough to have maybe great grandkids, I'm worried about those people with all the methane that's going to get released. So remember, methane is 23 times more absorbent in terms of solar radiation than carbon dioxide. And we haven't even seen the beginning of methane increases in the atmosphere. Anyway, so why does it go up and down every year? Okay, pause, go look it up. Okay, if you don't want me to destroy the suspense here. The reason is when you have an increase in carbon dioxide, I'm doing a video. When you have an increase in carbon dioxide, that's when respiration is taking place. That's when less photosynthesis is taking place, primarily in the Northern Hemisphere. If you look at a global map, the ones that's laid out flat, you'll notice most of the land surface on the planet is in the Northern Hemisphere. So you're going to have an increase in carbon dioxide because decomposition is taking place. Trees are dropping their leaves. Decomposers are going nuts. And remember, respiration, just like us, when we're respiring, when we're breathing, we exhale carbon dioxide. So you're going to have peaks in carbon dioxide primarily during the winter months, the fall and the winter months. Whereas in the summertime, when photosynthesis is taking place a lot more, it is pulling more carbon dioxide out of the atmosphere. So respiration, winter, summer, winter, summer, winter, summer, winter, summer, winter, summer. And you'll notice it continues to trend up. All right, getting ready to hop ahead to the next one. Okay, list 3 non-human factors that affect populations. If you're not sure, go take a look back at number 19. Yeah, so we got limiting factors, competition, predation, health, environment. There are others. I just did the ones that I thought were most important. 5 ways human impact the carbon cycle. It's pretty much the same as going back to the biggest threat to ecosystems, right? Okay, what do we got? We got deforestation, ocean acidification, burning fossil fuels, land use, using concrete, climate change. Pretty much the same as the human activities that are affecting biodiversity. We're jacking up the carbon cycle. Yeah. Does human activity, this is an opinion question, does human activity increase the amount of CO2 being put in the atmosphere? Are we responsible? Are humans responsible for climate change? Because there are many people, they're called climate change deniers or skeptics. There are many people on this planet that think this is happening and it would have happened regardless of whether or not humans are on the planet. We've had warming periods. We've had ice ages in the past. In your opinion, do you think we are responsible for all the chaos that's going on in the environment on this planet? You know my vote. Hell yeah, we're responsible, and we need to do something about it. All right? Maybe you do. Maybe you don't believe it. All right? If you don't, boy, I hope you're right. I hope things level out. I hope your kids and the planet they have and your grandkids and the planet they have turns out to be something like it was when I was growing up in the 70s and the 80s. And I hope at least you choose to live your life responsibly and not pollute and not use a ton of energy and vote the right way and raise your kids the right way, because, it's one thing to not believe that it's human caused. It's another thing to continue to live the lives we've been living, which have contributed to the problem. That's totally separate from whether or not you think we're causing it. And ladies and gentlemen, that is it. Okay, so again, these notes are due Thursday night at 9 p.m. Okay, I'm going to upload these to the Google Classroom in just a minute. Your movie worksheet. Okay, your movie worksheet is due Wednesday at 9 p.m. And don't forget, I've also got the study guide out on the Google Classroom. Get a good start on that. Try to get it mostly done by the end of the weekend. We will have some notes that are kind of going to talk about like how we can solve some of what's going on in the atmosphere. Those will be there will be some study guide questions that are going to be based on those notes, so you won't be able to answer the entire thing. All right, ladies and gentlemen, thanks for watching the video, and we will see you in the Zoom.